Hello everyone, welcome to Sri Chaitanya Academy, and also I welcome you to this special transition course. Now we are moving towards the next session where I'm going to talk about the chemistry transition course, the third class. In the last class we studied what is mole concept, right? We also talked about how mole concept can be used to get the number of particles, the volume of gas at STP, and also what else can you do? You can also find the mass of the substance, right? So in the last class, so before I do this, let me give you a quick recap of what we have done in the last class. So in the middle I wrote mole, right? On this side I wrote number of particles. On this side, I wrote mass, and below I wrote volume of gas at STP. Right. So you have to just remember how you can interconvert each of them into each other. Now, from mass, when you go to moles, I have already told you you have to divide by molar mass. Reverse, you have to multiply by molar mass. From number of particles, if you want to go into moles, simple, divide by the Avogadro's number, and if you want to go reverse, multiply by the Avogadro's number. Volume of gas at STP, if you want to know moles from this, how will you go? You will divide by 22.7 or 22.4, right? If it is 1 bar pressure standard, then you will use this. If it is 1 atm, you will use this. Now, how to get back? Multiply it by 22.7, right? So this is the summary which you need to memorize and remember to solve such questions. Now, this is a fairly simple question. Let's get a head start at it. Which of the following expressions is correct, where n is the number of moles of the gas, n is the Avogadro's constant, m is the mass. Let me take some other color. M is the mass of one molecule of the gas, n is the number of molecules of gas, right? So this is a direct formula. Number of moles, right? We know that if you want to go from moles to mass, or you want to go from mass to moles, how you can get? N will be equals to mass upon molar mass, right? So I don't think so that kind of a formula is anywhere visible here. No, right? It's not visible. So anywhere you can see this mass term, you cannot get the answer. Now, n is the number of molecules. Now for number of molecules, come here. So if you are going from number of particles to moles, the formula becomes how? You take the number of particles, right? So here you take the number of particles. So number of particles for us is n. So n will be equals to sorry. Let me tell you. You move from number of particles divided by Na, and then it will be equals to moles. So number of particles divided by Na will be equals to number of moles. So this you can further simplify as n equals to n into Na. So you can see where you can see this kind of an expression, you can see it in the third option. So third is the correct answer. Remember this. The volume of 1 mole of a gas at standard temperature and pressure is. This is a straightforward thing. Again and again I'm referring to this because this will help you solve almost all questions of mole concept. So now they are asking that volume of 1 mole of a gas at STP. We know that it is 22.4 or 22.7 liters, right? So this is the correct answer. Moving on. The charge on 1 gram ions. So remember that if they tell you 2-3 things I'm going to tell here. If they tell you 1 gram atom, or they tell you 1 gram molecule, it means What does it mean? It is exactly same as 1 mole of atom and 1 mole of molecule. Okay, right? Gram atom, gram molecule it literally means 1 mole. So if it means 1 mole, so 1 mole of aluminium. So let us see this, 1 minute. So now, so 1 gram ions of Al3 plus, right? So what I'm talking about is, I'm talking about 1 mole of Al3 plus, right? Now think about it, 1 mole of, now they are talking about the charge, right? So let us, before we move on to 1 mole Al3 plus ions, let us stop a little bit and think about how much charge does 1 ion of Al3 plus have. So if I talk about here, 1 ion of Al3 plus, the charge is 3, right? Or you can say plus 3. Now, if you have 1 ion, now if I want 1 mole means how many ions? Na ions, right? Remember, it is the Avogadro's number, 6.023 into 10 raised to the power 23. So multiply both sides by Na. So now you have Na ions of Al3 plus, this will be equals to 3 Na charge, right? 3 Na charge, right? So, okay. Now, people can see here the option is given as 4, but they can confuse you that the charge, this 3 Na, you will learn in the atomic structure chapter, this 3 Na is not actually the charge here. This is relative charge. Okay, this is relative charge, right? Charge, 1 unit of charge is, right, 1.6 into 10 raised to power minus 19 coulombs, right? This is your relative charge, 1.6 10 raised to power minus 19 coulombs, and this charge is represented by a small e like this. That's why they have multiplied by e and the answer is in coulombs, right? So 4th is the correct answer. These things will become clear as we move forward. Now let us move on to the next question. In which of the following pairs do 1 gram of each? Remember, this is 1 gram. This is not 1 gram atom or 1 gram molecule. It is just 1 gram. If they write 1 gram atom or 1 gram molecule, then that is an indication for you that they are talking about 1 mole. But here they have not written atom, molecule or anything else, then it's just the mass, 1 gram. So the mass given to you is 1 gram, right? Now, 1 gram of each have an equal number of molecules. So what they're basically saying is that you calculate the number of molecules in each of these, right? And then see where the number of molecules are coming as same. Okay. Now let's see this. Because the time is less, you can calculate for all of them, right? I'll do it because I can clearly see from my knowledge which can be the correct answer. So I will move directly to that. So let's see, and the same you can apply to everywhere else, right? So if I analyze the third option, let us see. Mass of nitrogen is given to you as 1 gram, which is equals to mass of CO, right? So remember that to calculate anything, if you are confused how you are going to solve a question, right, from the mole concept, remember that the chapter is called mole concept, right? It's called mole concept. Because it is called mole concept, the first obvious and logical thing to do is to calculate moles. So use that chart which I gave here and calculate the moles from this, right? And that is going to help you in getting at an answer. So, so we know that moles is equals to mass upon molar mass. So you need the molar mass of nitrogen and carbon monoxide. So molar mass, let us talk about nitrogen first. Molar mass of nitrogen is around 28, right? So these many moles of nitrogen. Similarly, you can get the moles of carbon monoxide, right? Carbon is 12, right? Oxygen is 16. Again, you will get a 28 as the molar mass, so this becomes 28 moles. Number of molecules, how you will get? Simply remember how you will do. Number of particles. So now you have to go from moles to number of particles. You have to multiply it by Na, right? So simply do nothing. Number of particles of N2 is 1 by 28 into Na, and number of particles of CO is 1 by 28 by Na, right? You can see they are equal. They are equal because the molar mass is equal, right? So simply, if they do not ask you the exact number of particles, so one rule of thumb is equal moles have equal number of particles, right? You can use this very easily and you can get an answer. Moving on. A quantity of aluminium. Now read this question carefully. A quantity of aluminium has a mass of 54 grams. What is the mass of the same number of magnesium atoms? So let me just simplify this question for you. I have taken some amount of aluminium with me, right? Suppose I have taken some amount of aluminium with me. Mass of that some amount is 54 grams, right? And in these 54 grams of aluminium, there are some number of atoms, right? So you have some number of aluminium atoms. So this is some number, can be 4, 5, 6, 7, 8, 9, 10, whatever, it can be some number. So this number, now the same number of magnesium atoms you are taking, right? Mass of the same number of magnesium atoms. So same number of magnesium atoms you are taking, and you have to find the mass of these number of magnesium atoms. Understand that this question, how similar it is. It is saying that if you have 1 kg of oranges, and in 1 kg of oranges you have 5 oranges are coming, right? In 1 kg oranges, 5 oranges are coming. Now it is telling you that, tell me the mass of 5 apples, right? That is basically the simplification of the question, right? So you, in 1 kg you have 5 oranges, the same number, 5 apples you have to take and tell the mass. So here, instead of that, from here you have to tell the mass of magnesium atoms. Now to tell this mass, you basically need this. Now again, this is number of particles. Again going back, from number of particles, how do you go to mass? You can't go directly. Number of particles you have to convert into moles, and from moles you have to go to mass. So number of particles you have to divide by Na to get moles. Then from moles you have to multiply by molar mass to get the mass, right? So that is what we need. So this is essential. Now how we will get to this? From mass to number of atoms. How we will get to mass from mass to number of atoms? Again, going back to that, from mass to number of atoms. Mass has to be first converted into moles, then moles has to be multiplied by Avogadro's number to get the number of particles. So I think it is fairly clear that no matter what you do, you have to arrive at the middle station, the changing station of moles. That is the center idea of this chapter. Now let us move back to our question, right? 54 grams. Now what is the molar mass of aluminium? They have given it to you for making things easy. So first and foremost, let us calculate the moles of aluminium. Moles is mass divided by molar mass. So let us divide it 54 by 27. So it comes out to be 2, right? 2 moles. Right. So now normally people convert it into atoms. So we can convert it into atoms also, no problem. So now if you convert it into atoms, how many atoms? Moles into Avogadro's number. So if I talk about atoms, so let me clear this out a little bit. Right. So number of atoms of aluminium will be 2 into Na. This is same as number of atoms of magnesium, right? Atoms of magnesium, right? So from number of atoms, now you are going to moles, right? So what we are going to do for that? Number of atoms, you are going to moles, d divided by Na. So moles of magnesium comes out to be 2 into Na by Na, 2 moles. After you have that, now you have to move from moles to mass, right? So mass will be moles of magnesium into molar mass of magnesium, which is 24. This comes out to be 2 into 24. 48 grams. See if anywhere it is there. Yeah, third is this there. It is the correct answer there. Now, which of the following samples contains the largest number of atoms? Again, don't think much. If you do not understand, just move towards calculating the moles, right? So move towards calculating the moles, and I'm telling you that is the mantra that will get you through most of the questions in this chapter, right? So we know that moles is equals to mass upon the molar mass. Now, I told you that if you want to get number of atoms, what you do? You multiply moles by Na. We just did this in the first question, right? So can I say that number of atoms is directly proportional to moles? Right. And moles is inversely proportional to, you can see here, inversely proportional to mass. Sorry, molar mass. So as this molar mass decreases, so as your molar mass decreases, what will happen? Your moles increases, and because moles is directly proportional to number of particles, N also increases. So I can say that as molar mass decreases, number of particles increases, right? So so what we essentially have to do, we have to maximize number of particles. That we can do if you minimize the molar mass. So you have to check the least molar mass here. The least molar mass here is for boron, which is 10 grams per mole. Rest all of them have a higher molar mass, right? Like this has 20, this we have already calculated 28, right? So like this you will get. which of the following contains the greatest number of oxygen atoms? Now remember, here they are saying oxygen atoms, right? Oxygen atoms, not molecules, atoms, each single oxygen atom. So, greatest number. So let us analyze each option one by one and then arrive at a probable answer. So first option, how will you find number of atoms here? Again, go to number of moles. So for this, number of moles of O will be 1 grams by molar mass of oxygen, which is oxygen atom I am talking about, which is 16. Right. Now from this, if I want to go to number of particles, just we did, you have to multiply it by Na. Right, so this gives me the number of O atoms in the first case. Similarly, I can talk about the second case. In the second case, right? But understand that each oxygen molecule has 2 oxygen atoms, right? So to get oxygen atoms, you need to multiply this by 2 because it is the double value, right? So now number of moles of oxygen molecules will be 1 divided by 16. Is it 16? No. It is 16 multiplied by 2 because you have 2 oxygen atoms, right? And that itself is multiplied by 2, right? And then Na is there here already. So if you cancel this out, for this option also, you will get 1 by 16 Na as the number of O atoms, right? Okay. O3. So number of O atoms for O3, how will you calculate? Again, number of moles of O3 multiplied by 3 multiplied by Na. So if I do this, quite simply, 1 by 16 into 3 into 3 into Na. Again, yes, this is a trick question. Again, you can cancel this out. Again, you will get 1 by 16 Na as number of oxygen atoms. So now, when you are getting 3 correct answers, right, it means all have the same number of atoms, which is 1 by 16 Na, 1 by 16 Na, 1 by 16 Na. Fourth is the correct answer. Moving on. A sample of ammonium phosphate contains 3.18 moles of hydrogen atoms. So one thing I wanted to tell you is that understand that if I have a, instead of this, let me take an example. If I have H2O molecule, right, H2O molecule, for that matter, one H2O molecule, right. This one H2O molecule has how many? 2 hydrogen atoms and 2 oxygen atoms, correct? Now, I can multiply this complete equation by Na very easily, right? So, let us multiply this complete equation by Na. If I do that, see what will happen. You will have here Na, H2O molecules, here 2 Na, H atoms, and here 2 Na, O atoms, right? Na means what? Na means 1 mole. So here you are having 1 mole of H2O molecules equivalent to, now 2 Na means 2 mole of H and 2, this is not 2, sorry, you can just cut this out, it's just 1 O, right? So 1 mole of O. So understand that a formula, as you write it, from the formula you can directly conclude that 1 mole of water contains, so this formula can represent 1 mole of water contains 2 moles of H and 1 mole of oxygen. Now, following on the same principle, you can solve this question. Only the formula is a little complicated to confuse you, but calm down, do not get confused. Have your safe space in logics, right? So, a sample of ammonium phosphate. So, you have ammonium phosphate. As you see the formula, it should strike you what? In ammonium phosphate, we are talking about hydrogen atoms. So, 1 mole of, what is written here? 1 mole of ammonium phosphate. This will be equivalent to how many hydrogens? 4 3s are 8, 12, right? 4 3s are 12, right? So, you will have 12 moles of hydrogens, correct? Now, this we know. The number of oxygen atoms in the sample is. Understand this very carefully. It's a little twisted question. So, this, and we also know that 1 mole of this contains how many moles of oxygen? 4 moles of oxygen, right? Let us keep this slide. This is fairly important. You'll keep it in the PDF. Let me take a new slide, right, and move forward from there. So, we know this, right? The number of moles of oxygen atom in the sample. So, now understand that we have a direct relation between moles of hydrogen and moles of oxygen. Is it correct or not? Yes. So, 12 moles of hydrogens are equivalent to 4 moles of oxygen. Then the question I will ask here is, these many moles of hydrogen are going to give how many moles of oxygen? Let us find that by the unitary method. So, you have 12 moles hydrogen equivalent to 4 moles of oxygen, right? That's about it. So, simply divide both sides by 12. So, now you will get 1 mole of hydrogen equivalent to 4 by 12 mole of oxygens, right? So, remember that you have to make that quantity whose value is given in the question. So, you have 3.8 moles of hydrogen. If 1 mole of hydrogen is equivalent to these many moles of oxygen, then 3.18 moles of hydrogen will be equivalent to how many oxygens? Multiply this by 3.18 both sides. So, 3.18 by 1, 4 by 12 into 3.18 oxygens, right? So, this becomes 3. If you divide this, you will get 3 ones are 3. Right? And somewhere around this, right? 0, 3 4s are 12, right? 1.04 around. 1 minute. 3 point. Okay, it's 3.18, not 3.14. 3.18. So now a little bit more correction. Is 1.06, right? 1.06. You can see this in the third option, right? So third is your correct option. Yes, these questions are not direct. I'm leaving this, right? The PDF of this session and the questions here you will get in the Telegram channel. So, yes, hi Ganesh. Thank you for joining in, right? So, you can ask any doubts if you're getting in the solving of questions which I'm doing right now, right? Moving on to next. How many moles of electrons weigh 1 kilogram? So, mass of an electron is around 9.1 into 10 raised to power minus 31 kilograms, right? So 1 kilogram is the mass that is given to you. This is what? This is mass, right? Hi Gajendra, good, nice for joining in, right? So we already know, right, that you can convert mass to moles by dividing by molar mass. So find the number of moles of electrons by dividing mass of electron by molar mass of electron, right? But you don't have anything called molar mass of electron, right? What is molar mass of electron? What is the definition of molar mass? Molar mass is the mass of 1 mole particles. 1 mole particles, how many particles are 1 mole particles? 1 mole electrons means how many? Whoever have joined can tell me 1 mole electrons in the comment section. How much does it mean? How many number of electrons 1 mole means? It means 6.023 into 10 raised to power 23 electrons, right? That is what it means. So if you multiply this by mass of 1 electron, you will get mass of 1 mole electrons, right? 10 by 23, no, right? 1 kilogram they are saying, right? So 1 kg, 9.1 into 10 raised to power minus 31. This is the mass of 1 electron multiplied by Avogadro's number, that is 6.023 into 10 raised to power 23, right? Let me just remove this line, right? You can see here what I have done here, right? Moving forward, all are in kgs. 23 minus 20 minus 31 comes out to be around 10 raised to power minus 8. So it will be 1 by 9.1 into 6.023 into 10 raised to power minus 8, right? And this goes up, it becomes 1 by 9.1 into 6.023 into 10 raised to power 8, right? So this expression, see, don't now just land up and try calculating it, right? Don't calculate this without seeing the options. See the options. Do we need to calculate it? No, the options are given just like this. So you can see this option matches with our answer. So this is the correct answer, right? The people who are joining in, please fill the Google form. At the end of this session, I will also tell you the link of Telegram channel. Join in there so that we can connect with you, right? So, how many moles of Na plus ions are present in 20 ml of, okay, this question is from a next topic. I'll discuss this next, right? This is not of this topic, yeah, here. If 1 by 1 by half, what does this mean? It is a mixed fraction, right? This means what? This means 1 plus 1 by 2, right? This is what? This is 3 by 2, right? So 3 by 2 moles of oxygen. Now here remember, 3 by 2 moles of oxygen combined with aluminium. Remember that oxygen which they are mentioning here is not oxygen atom, because oxygen atom just like that does not combine with aluminium. They are talking about oxygen gas. Oxygen gas means they are talking about O2, right? So the equation basically what they are talking about is they are talking about O2 combining with aluminium to form what? Al2O3. Now in mole concept, when equations are involved, the first thing that you have to do is to balance that equation out. Now how will you balance this equation out? You will write 2 here, and here you will write 3 by 2. 2 cancels out, you will get 3 O's, and here you have 3 O's. Equation is balanced. Let's move to next part. They have given you 3 by 2 moles of oxygen. So you have 3 by 2 moles of O2. Now this will combine with, see, from the equation itself it is clear, I don't have to go any forward, right? So this becomes 2 moles of aluminium. So the weight of aluminium, they are asking you weight, asking you mass. Now to remind you again, in the starting of this session, I have given a very nice diagram, right? How will you convert mass to moles? How will you do that? You divide it by molar mass. And the reverse, how will you do? You multiply by molar mass. So here I have the moles of aluminium. Here I have the molar mass of aluminium. So the obvious thing is, to get the mass of aluminium, I just have to multiply the moles of aluminium by molar mass of aluminium. The moles here you can see is 2. So multiply 2 by the molar mass, 27. You will get 54 grams. This is the answer, right? So more number of questions you will solve, more easier it will be for you. Moving on to the next question. Carefully read this question. These kind of questions are specifically asked in JEE and also in NEET. These are the statement type questions. So 2 sentences are written. Statement is just another English word for sentence. So you have to just check whether the sentence written is true or false, whether it is correct or not. 16 gram each of O2 and O3 contains Na by 2 and Na by 3 atoms respectively. Respectively means that in the order which it has come, right? So from 16 grams they are talking about for this O2, they are referring to this, and for this O3 they are referring to this, right? So we have to calculate the number of atoms. So now let us calculate the number of atoms. We know that number of atoms, suppose let me talk about O2, is equals to number of moles of O2, right? Now, number of moles of O2, if I multiply it by the Avogadro's number, what I will get? I will get the number of molecules of O2, right? Number of molecules of O2. Now, each molecule of O2 has how many atoms of O? People in the comment section tell me each molecule of O2 has how many atoms of O? It is clearly visible how many atoms? 2 atoms, right? So, if I want to calculate the number of atoms, I need to multiply this. This is for number of O2 molecules. But if I want the number of O atoms, then I have to multiply it by 2, right? How can you calculate the number of moles? Again, mass divided by molar mass. So 16 divided by 16 into 2 is the molar mass into Na multiplied by 2. It is a similar question. We have done this. Number of O atoms will be Na. Right? It will not be Na by 2. So the first statement you have to not analyze it further. This is false. Or I can say incorrect. Right? It is not correct. Statement 2. 16 grams of O2 and O3 contains the same number of atoms. Do they contain the same number of atoms? Well, to find that out, let us calculate the atoms of O3. Here also nothing you have to do. Simply, this is for O3. Calculate the moles of O3. First, see, when you have to calculate the atoms, no, just calculate first the molecules and then check in one molecule how many atoms are there. That number you multiply with this, you will get the number of atoms, right? So this is the number of molecules of O3. You can see 3 here. So multiply it by 3. Now the formula for moles of O3 will be mass of O3 divided by molar mass of O3, right? So 16 grams 3 oxygen atoms, 1 oxygen atom is 16. 3 will be 3 into 16 multiplied by Na multiplied by 3. Can you tell me now, is the second statement correct? The people who are watching right now, is the second statement correct? That 16 grams of O2 and O3 have the same number of atoms. Please respond. Yes, K ln 003. You just cut these things out. You can cut them out. Right? This cuts out. Again, you get Na atoms. So Na atoms here, Na atoms here. So they are the same. The second statement is true. So the first statement is false and the second statement is true. Now this will be the last question that I'm going to attempt today. Calculate the number of molecules in a drop of water. Yes, nice question, right? I am talking about of a drop of water. Let me take blue color just for having a creative liberty. So you have a drop of water, right? Now in that drop of water, the weight of that drop is 0.07 grams. So how many molecules of water are present in this? See, we never think that it can be related like this. Yes, this is the power of mole concept. So this is the mass. I told you to calculate number of particles, you have to arrive at the station of moles, right? From mass to moles, how you will go? Moles of water will be 0.07 divided by molar mass of water. Water has H2O, 2 hydrogens. For 2 hydrogens, you will have 2 grams. For oxygen, you have 16 grams. It will come out to be 18, right? So put that 18 here. These are the moles. Now how will you go from moles to number of atoms? Yes, correct. N into Na, correct. K ln 003, you are absolutely correct. Please refer to this first slide of this session and join our Telegram channel to get an exclusive PDF of this session and also few more worksheets, right? So 0.07 by 18 multiplied by Na. If you do that, you will get the number of water molecules, right? And what is the value of Na? I hope you know, 6.023 into 10 raised to power 23, right? So there are few more questions here. One more question here. You can use this as a homework question, right? One more here. Note this down. This is also an interesting question. Whatever I have talked till now, whatever formulas I have discussed, nothing is out of that. Apply all that, rewatch the session, and then attempt this question. I guarantee you 100% you will be able to solve them. Again here, this also is a homework. With this I end this session. But what does not end, the people who have joined in, please join our Telegram channel. Scan this QR code in Telegram channel. Every day we are posting new things, new questions, important shortcuts, tips, tricks. Many things are there. You get it absolutely free. Nothing is charged, right? Nothing is hidden here. Everything is free. Knowledge is free at Sri Chaitanya Telegram channel. And so that we get to know you better, scan this code, fill in the Google form, right? Give us your contact details so that we can contact you and give you few more free goodies. So stay tuned, whoever has joined now. There is a math session coming up next, right? So bye from now, from my side for this chemistry section.